Yeah, dear student participants, I welcome you to lecture 37 of micro irrigation engineering subject. In previous lectures, we covered all the necessary equipment. We dealt with micro irrigation components. We covered the design of micro irrigation system. We design micro irrigation system by taking example. We also discussed in previous lecture 36 how to design a drip emitter, and we also exposed you to the how to use the basic fundamentals of fluid mechanics equations, continuity equation, Navier-Stokes theorem for the design of drip emitter, SolidWorks software, how 3D printer it can be used to develop drip emitter. To get more detailed information and to carry out more examples, numerical example, this particular lecture where we will be discussing on numericals problems on drip irrigation system. These problems will be dealing with the determination of water requirement of crop, how to determine the emitter discharge from the given weighted area, and how to evaluate the drip emitters, their performance in terms of emission uniformity. So, let us start working by taking question 1. So, in question 1 we have been given the spacing between adjacent plant row is, that is 1 meter, spacing between drip emitter is 0.5 meter. We need to determine the area irrigated by the drip emitter if its weighting is 90%. So, it is a simple problem. We are required to find out the area irrigated by a single dripper, and similarly we can find out when there are large areas where more number of the drippers are to be placed. So, this way we can find out how much weighting can be made. So, it is a simple question, spacing between the drippers and then row to row spacing of the plant, that is L equal to 1 meter. This is the thing which is given. We are given spacing between the emitter, that is 0.5 meter, and then weighting percentage 90%, and then number of dripper is for each plant is N equal to 1. So, area irrigated by each individual dripper is area an area of the plant, that is we can say spacing between, means the plant rows and spacing between the emission points. So, this area, that is L into S, and then that is to be multiplied by the weighting percentage. So, this is also given to us, that is 90%, and number of dripper is N equal to 1. So, we are just substituting these values, we can find out the area irrigated by a single dripper. So, area irrigated by a single dripper is it is, after substituting the values, it is coming 0.45 square meter. The question 2 is we are given a pan evaporimeter data and where the value is given for the month of April pan data. This is the pan evaporation is given 6 millimeter per day, and then the we here we are given data as a pan coefficient is 0.8, crop coefficient is 0.7. The individual mango plant, it has a each individual plant area of 25 square meter. Normally, the hybrid varieties of mango plantation, Amrapali, it is now these are being given high density planting, it needs continuous pruning. So, 5 meter by 5 meter is the normal spacing given for these Amrapali variety. So, here 25 square meter is the spacing. Now, if the percentage of the weighted area covered by the plant foliage is 60%. So, here this is the beauty of the drip irrigation system. We need not flood the whole area, only the effective portion which is where the root zone exists, only 60% is being irrigated, particularly for wide spacing crop like mango, citrus, sapota, such type of group crops. Normally their maximum range is 60%. So, here it is a 60% weighting is given. Determine the total crop water requirement for 1 hectare area. So, we have been given pan data, it is a pan coefficient value is given, we have been given crop coefficient data, we have been given each individual plant data. So, we need to find out the evapotranspiration of the crop. So, let us first once again these data has been given, that pan value is 6 millimeter per day, pan coefficient is 0.8, crop coefficient 0.7, each individual plant area or tree area is 25 square meter. When the plant is at the fully maturity stage, 60% weighting is being done, and then total area where the plantation is done, it is 1 hectare. So, water requirement of each plant can be estimated by using this expression E T naught. So, E T naught to be found out from E pan and K P. K C will give us, so E T naught into K C is the evapotranspiration requirement of the crop, and S P into S R, this is the spacing between the plant and spacing between the rows. So, this is also given 25 square meter, and then weighting percentage is given as a in this particular thing, this is W P. So, this W P is 60%, this is given. So, we are substituting the value that Q equal to 6 millimeter. So, 6 into 0.8 into 0.7 into 25 multiplied by 0.6. So, this is giving the 50.4 liter per day per tree, because it is a mango plant which is when it has reached to 60% weighting, when we are giving means it is a fully matured crop, and in the month of April daily water it is given as a 50.4 liter per day. So, if I know the total number of plants, if I know the total number of plants for the whole area, then I can multiply the so, in 1 hectare area we can see this is the spacing is 25 square meter for each plant. So, 1000 is 10,000 square meter divided by 25 square meter, this will give us the total number of plant. Then we have to multiply with the water requirement of a single plant or single tree. So, this way we are getting here 50.4 liter per day, 10,000 divided by 25. So, this is the total water requirement per day for the 400 number of plants, because for 25 square meter each plant area when it is being given. So, it will be 400 number of plants. So, one day itself this much amount of water is required. So, this is the answer of this question. For more details I can tell here, if I want to make a planning. So, then for the whole summer month what will be the total water requirement, and accordingly one should make plan. One should make plan for the seasonal water requirement, one should make plan for the annual water requirement, that this will be the total water requirement. So, we should have enough capacity of water storage. If it is a flowing river, then also one should see whether this water will be available during summer month daily, or somebody wants to store water in a pond or a well, or one wants to design the system for using the pump. So, my pump should also work. So, how many hours the pump will operate, that can be worked out also in a day. So, that should be the discharge of the pump. Now, the question 3, here it is given point source drippers of 4 liter capacity has been manufactured by a manufacturer, that is the this is the development, that is the drippers are having 4 liter per hour capacity, that is being manufactured. The performance test is conducted for 10 numbers of randomly selected drip emitters. So, 10 number of drip emitters have been selected from the randomly from the lot when it is being manufactured. Now, when they are being brought from the testing. So, the data which were obtained, actual design discharge is 4 liter per hour, but when we are testing it in the test bench, hydraulic test bench, we find that these data are available, that is 3.8, 3.85, 3.6, 4.1 like this. So, discharge, you can see the data which are available. This is varying from 3.6 liter per hour to maximum 4.1 liter per hour. So, this is the variation in this range. These 10 number of observations are obtained. So, from these data we are required to determine the coefficient, manufacturer's coefficient of variation. Now, and then for the test sample, and also we need to see that whether does it qualify the particular value. So, we will what we are doing it here, we are given n equal to 10, and then we need to find out the manufacturer's coefficient of variation, that is the standard deviation divided by Q average. So, the standard deviation is estimated by the taking the each individual observation, those 10 number of observations individually, and then from there we are finding out the average, that is these are nothing but discharge from individual observation minus the average of 10 divided by total number of observation, that is your 10 minus 1, that is 9, and accordingly we will find out this coefficient of manufacturer coefficient of variation will be estimated. So, each individual values are estimated, and we find out the deviation from each individual values, and then we find out the sum of these deviation. This is the average value 3.873, and then we find out the coefficient, manufacturer's coefficient of variation, and this is 0.039. So, the for point source drip emitter, for point source dip emitter, the emitter should be of excellent quality, it should be less than 0.05. So, this qualifies the test. This is a important parameter whether it qualifies. Now, this manufacture coefficient of variation, why does it come? Because this is a thermal processing process. When the particular material it is a passing through the machine, it is given certain temperature. So, there may be some defect, there may be some malfunctioning of some certain components. So, it may not be delivering same. So, this is a important test, and Bureau of Indian Standard as well as American Society of Agricultural Engineers, they have prescribed the test and given this table that for point source emitter it should for whether it is in excellent quality, good quality, very poor quality, then lot should be rejected. So, this when we have taken these 10 samples and we found out the CVM value, this qualify, then this should be accepted for use. The problem 4, it is given, determine the emission uniformity of drip system that uses drip emitters with the coefficient of discharge. Here coefficient of discharge is given as 0.35, exponent x is given as 0.6, and coefficient of variation just now which I have explained you in the previous problem, that coefficient of variation is 0.06, and then the 2 emitters which are used for each plant, means there are 2 emitters for each plant, that is the requirement to meet the water requirement. And then average pressure, operating pressure is 110 kilopascal, and then the minimum pressure it is within 95 kilopascal. So, these are the observations which are given. We know the discharge from a drip emitter, it is a function of operating pressure. So, this is a function of operating pressure. So, this is given by expression that discharge from a drip emitter is coefficient of discharge and operating pressure H to the power x. So, in this particular question, we have been given coefficient of discharge, we have been given the value of x at 0.6, we have been given the value of h. There are 2 h, one is the average h, another one is the average h. This is the minimum h, that is operating pressure, this is your average operating pressure. We have been given coefficient of manufacturer's variation, and each plant is given 2 numbers of point source drip emitters. Here in case of the this your particularly when we want to do so point source emitter, we are considering number of drip emitters. In case of line source drip emitters, we consider the length of drippers. So, there we are considering all the time 1. So, here with the 95 kilopascal pressure, when we are substituting the value, we get here this is 5.38 liter per hour. This is the discharge, that is a minimum discharge, and then for the average pressure, that is a Q2, we can be find out by using these values in this equation, and then it is a simple thing, we get 5.87 liter per hour. So, these values we will be substituting in the emission uniformity formula. Emission uniformity formula for a drip emitter is given by 100 into 1 minus 1.27 multiplied by coefficient of variation, that is 0.06 divided by square root of number of drip emitters, and these are nothing but this is a Q min, that is the minimum discharge in liter per hour, this is your average discharge, that is 5.87, and then when we calculate, we get the value as 86.71%. So, this is the answer for this question. This is within the permissible limit. So, operating these particular drippers which have been kept there, they are working nicely, and then this is above 85%. Question 5, it is also we have been given the data, we are required to find out the emission uniformity in the same way, but more number of observations are available and questions have been solved in a different way, some other data which have been given. So, let us try to work out data which are given. There are two point source emitters on each pantograph is, it has been used. So, N E is the same as it was in the previous case. We are using the terrain is laid, it is on the slope, it is a means it is a slope is less than 2%, and then the coefficient of variation, that is manufacturer's coefficient of variation, it is the CVM is given as 0.07. The discharges from 15 numbers of drippers which has been collected from the field are given here. So, these values are also available to us. So, means for 15 observations, these are the observations which are given. So, we have been given N E equal to 2, CVM equal to 0.07, and the just now we gave this same expression, I am repeating here. Emission uniformity is estimated by this equation, which is 100 into 1 minus 1.27 multiplied by the coefficient of variation divided by square root of number of emission points or emission devices, and multiplied by the ratio of Q mean to Q average. So, we need to find out what is Q mean, we need to find out what is Q average. So, Q mean already in the data it is given, means we from the data which you just see here in this particular data, we have got this value as 9.6 out of the total 15 number of observation. The minimum value is 9.6 liter per hour. So, this is the value which is available from the data, and then all these 15 data were used to obtain the Q average. So, just we have taken sum of all the observations of 15 values divided by 15. So, this is giving Q average equal to 9.96 liter per hour. Now, simply we are substituting the value, and this value it is substituted by keeping the this particular observation. So, this is given by emission uniformity 100 multiplied by the 1 minus 1.27 into 0.07, that is divided by square root of 2 multiplied by the minimum discharge, that is 9.6, and then 9.96 the average discharge. So, emission uniformity is 90.32%. So, this is acceptable value when we are taking these observations from the field. So, this can be accepted, and this is the result of this particular question. Question 6, it is on the let us read this particular question. Is surface drip system is laid on 16 hectare level orchard field. Okay. Level field in a orchard, and trees are planted on 7 meter row spacing and 5 meter spacing between the rows. So, row to row spacing is 5 meter, and then the plant to plant spacing is 7 meter. Then drip system irrigation is drip system should achieve at least 85% of the design emission uniformity. This is the condition. It is given that the emission uniformity should be greater than 85%. There are 5 number of non-pressure compensating drippers have been used for each tree. 5 number of drippers which has been used for each tree at a spacing of 1 meter and which operate at 1 kg per square centimeter pressure. So, drippers are operating at 1 kg per square centimeter. Manufacture coefficient of variation is 0.03. Average design pressure is 4 liter per hour. The hydraulic relationship for the same dripper means Q with the operating pressure discharge relationship is Q equal to 1.33 S to the power 0.48. So, this is the relationship which is given. Determine the operating pressure head of the drip emitter discharging minimum discharge, which is delivering minimum discharge. So, for this we will find out what is the operating pressure. So, from these given data we have been once again I am given we have been given target that EU should be 85%, average discharge of the dripper is 4 liter per hour. Okay. Then manufacture coefficient of variation is 0.03. Each tree is given 5 numbers of non-pressure compensating or drip emitters. The coefficient of discharge, the equation which has been given C d equal to 1.33 and then the exponent is x equal to 0.48. This particular equation it has been again repeated, that this I am not reading. The emission uniformity is given by this equation and then we are we can write actually this q mean from this equation we are changing the means rearranging the equation, that q mean can be written as the EU multiplied by the q average divided by 100 into 1 minus 1.27 coefficient of manufacturing variation divided by square root of n e. So, from here we can get the value of q min. So, just we are substituting the value that u is given 85%, discharge average is 4 liter per hour and this is the CVM is 0.03, now n e equal to 5. So, substitute after substituting we get minimum discharge as 3.46 liter per hour. So, we can find out the operating pressure by using the expression. This is already given. We have been given the value of the coefficient of discharge and then we have just now we have calculated the discharge, that is 3.46 liter per hour. So, H can be obtained. So, H can be given by from this expression 1.33 multiplied by H to the power 0.48 equal to 3.46. So, H is 7.5 meter. So, this is the minimum operating head in the emitter that will deliver the discharge of 3.46 liter per hour. So, this way we have estimated this particular value, desired value which was asked in the question, and now you can refer more problems for your practice by referring these books, and these are the standard textbooks which I have been using it in other classes also. So, refer these books for more detail and let us summarize this particular lecture. So, we worked out the numerical problem to find out the water requirement of the crop when we are using micro irrigation system, that is a drip system. We also worked out how much is the area covered by a particular dripper or weighted by a drip emitter. We worked out how to determine the emission uniformity of drippers. We worked out from the given emission uniformity how to find out the minimum discharge and minimum operating pressure. Now, in forthcoming lecture we will discuss about the micro sprinkler irrigation system. Thank you very much for your patience hearing.